to learn derivatives of logarithmic function under the chapter differentiation from mathematics to grade 12. So see students, when we are going to solve derivatives of logarithmic function, the most important question arises when to use logarithmic function. Means there are lots of types of function where we have to differentiate, and in that when to use logarithmic differentiation. Next question arises, what are the rules of logarithm that we have seen in 11th standard, but what are that rules used for logarithmic differentiation? Next is, what is the method of solving for logarithmic differentiation, and then we will proceed for a example. Okay. Now the question arises, when to use logarithmic differentiation. So what are the conditions wherein the logarithmic differentiation can be used? So we have three conditions when the logarithmic function differentiation is used. First condition is when there exists product of three or more functions. When there exists product of three or more functions, logarithmic differentiation will be used. For example, if we are having y is equal to product of fx into gx into wx function. So now why not 2? So see here, if my function is y is equal to sin x into log x, means what? It is a product of two functions fx into gx. And here we can easily use derivative of u into v rule. Okay, hence the product of two function is possible with the u into v rule, but product of three or more function is not easily possible, hence we have to use logarithmic differentiation. Okay, now see students, if y is equal to sin x into log x into, I am taking one more function as e raised to x. So this is the differentiation of three function. Now here we have to use logarithmic differentiation. That is our first condition, product of three or more functions. Okay. Now second condition is when there is a division of three or more function. Same, if I am observing my y function is equal to fx upon gx into wx, or I can say that another is y is equal to gx into wx upon fx. That means three functions are involved in a division. Then I have to use logarithmic differentiation by using logarithmic rules. Okay. Why is it so? Again, if I have my y function is equal to sin x upon log x, then we are observing that it is a division of two functions sin x and log x. When there is a division of two functions sin x and log x, we can easily use rule u by v. Hence, it is differentiable with the quotient rule u by v. But if I included one more function or more than three functions, that means if I am taking anything else into e raised to power x. So it is a multiplication of three functions sin x, log x and e to the power x. Hence we can't use here a quotient rule. Hence we are using logarithmic differentiation. By condition 2 we have to use again logarithmic rules for differentiation of division of three or more functions. Okay. Now our last condition is condition 3, and very important condition is when a function raised by another function. I have one function fx and another function gx as an exponent of it. Then I have to compulsory use logarithmic differentiation, and in that the exponent rule of logarithm is applicable. So in such a kind of differentiation, logarithmic differentiation is used. If I take example, as an example I can take y is equal to sin x raised by log x. That is sin x, one function of x is raised by another function of x. In such a kind of differentiation also logarithmic differentiation is used. So that's how we are answering the question when to use logarithmic differentiation. It's very simple by using these three conditions. Okay. Now our next question is, what are the rules of logarithms used for logarithmic differentiation? So we have three rules of logarithms used for logarithmic differentiation is product rule, quotient rule and exponent rule. Now let's see our first rule, that is product rule. We have already studied in 11th. The product rule of logarithm is log mn is equal to log of m plus log of n. So same rule is applicable in logarithmic differentiation, which is used for our condition 1. What is our condition 1? That we have written in previous chart. It is a product of multiple function, that is 3 or more function. So I am taking product of 3 or more functions. Y is equal to fx, gx and wx. Okay. So when I am applying logarithmic rule, for that log y will be equals with log of fx plus log of gx plus log of wx. Means what? Logarithm of each function gets added. We have to take sum of logarithm of each function. Our second rule is quotient rule. Quotient rule in 11th is as log of m by n is equal to log m minus log n. Means what? After applying logarithm, that term gets subtracted. Same rule is applicable here. If my function y is equal to, now we have to use this rule for condition 2. Condition 2 in previous chart was division of multiple functions. So I am taking example y is equal to fx upon gx into wx. So when I am applying logarithm, it will be equals with log y is equal to log of fx, that is numerator function, and all denominator function logarithm gets subtracted, means minus log of gx minus log of wx, which is a quotient rule. Now let's discuss our third rule, that is exponent rule. So exponent rule is used for our condition 3 in previous chart, and it was a function raised by another function. Okay. So the exponent rule in 11th was log of m raised to p is equal to p log n. So if I have taken example of y is equal to fx raised to gx, in that gx is an exponent. If I apply log on both sides, it will be equals with log y. Whatever is exponent function, take it forward. So gx is multiplied with the log of fx. This is my exponent rule. Likewise, all these three rules are used for all these three conditions of logarithm.